Hello guys, welcome back to another video in the Finance of Python series. This is Anirudh here, and today we're going to be looking at the NumPy library. So NumPy, in short for numerical Python, is a fundamental library for numerical computations in Python. NumPy provides support for large multi-dimensional arrays and matrices, along with a collection of mathematical functions that you can perform on these arrays. And this is what makes it very powerful. Now, why do you think NumPy is so widely used across various fields? There are a variety of reasons, and some of them are the efficiency with which it is able to handle large data sets effectively, the speed with which it's able to carry out operations with these arrays. So if you want to perform complex arithmetic operations on two or more arrays, is able to manage this fast because NumPy has been the major chunk of NumPy has been built on top of C, making all these calculations and computations faster. And vectorization is another feature. So vectorization means you're able to perform operations on entire arrays without using loops, leading to more concise and cleaner code. And you also have an ecosystem in Python, especially because you can use NumPy along with pandas and matplotlib. So now let me just go over to the collab environment. So if you want to install NumPy on your laptop, you can just type in install NumPy. So that should work. Collab already comes with NumPy pre-installed, so you don't necessarily have to install it, but I'm just showing you how to install NumPy just in case. Okay, so now let's import NumPy as NP. Why do you think we should use NumPy? We have the list structure in Python, so why would anyone use NumPy? So just to show you the speed difference. So here we have tried to create two arrays, one using the NumPy a range function and another using our conventional list function. We can run this. Let's try to do some operations on these arrays that have been created, and let's compute the time that's taken. So let's use a time at function, use a new array, and multiply the first array by 2. Yes. So this is how long it took for the NumPy array to get multiplied by 2 completely. Now let's do it with the array, the list. Percentage time it my 3 equal to my underscore list into 2. Yeah. So you can clearly see the results over here. So a normal list takes about 10 times more time, consumes 10x more time compared to NumPy. So this is the speed advantage that I'm talking about, and this is per loop. So now when this is compounded over huge data sets, it makes a really huge difference. And so when there's a lot of data, especially in the field of finance, when you are analyzing a lot of real-time market data, you have a lot of variables. It is always wiser to use NumPy rather than a regular array to store some of these values, because you can perform certain computations on uh, data stored in NumPy arrays in a much quicker manner. So we have tried to showcase the speed difference here. Now let's go over some basics of NumPy. How do you create a basic array? So data equal to NumPy dot array of, let's say you want to create two-dimensional array. 1, 2, 3, 4, 5, 6 data. So this is how a NumPy array is represented. Then let's do some operation on the data array that we've created. Data to 10. So you've multiplied by 10. These are some basic operations that you can do. Then you can add the arrays together. Yes. Now, if you want to get, the dimensions of the array, you can give the data dot shape function and you will get it. Now you want to see the data type of, the array inputs, then int 64. Yes. So all these are integers. So let's now just see how to create a NumPy array from a regular list. So let's say you have a regular list like 6, 7, 8, 9, 10. You can just say, you can just use another variable called, let's say, NumPy underscore array equal to np dot array of data one. And sorry, just, yeah, and now print. Yeah, so now this is a NumPy array. In addition to the NumPy dot array function, you have a number of other functions for creating new arrays. So for example, if you want an array with just zeros or just ones for a specific dimension, you can do that as well. So let me show that. P dot zeros. You just want zeros. And now let's specify a dimension. Let's say we want a 4x3 array. Sorry, a 4x3 matrix filled with zeros. We have a 4x3 over here. Now, if you want them to be filled with ones, just say np dot ones 4x3, and you'll get ones over there. It's pretty basic. You also have a dot empty function, which will just create a new array by allocating new memory, but it will not, populate the array with any sort of values. As you can see, if I take another dimension, it's very random. There are some zeros here and there. There's a random value. So it's not necessarily fully one or fully zero or any specific value. It's just, you know, um, just filled with garbage values unless you populate the array with new data. Now let's move over to some arithmetic capabilities of NumPy arrays. So here we'll be looking at certain features like vectorization. So we have, let's start off with a new array. And now let's calculate array into array. Yep. So here you can multiply the two arrays. So what it means is that you are just multiplying the elements of corresponding positions and making it into a new array. You can add arrays, you can subtract arrays. So all of this is possible. You can also do a one by the value of the arrays. So it's basically like this 1 by ARR. So you get 1.5, 1 by 3.33, and so on. You can do your exponentiation and all of that. You can also compare the values of two arrays, using, let's say, a logical statement. So let's take another array. So this is a new array that we are initializing. Now, let's say you want to see if the elements of the second array are greater than the elements of the first array. So you can just say array2 greater than the array that we initialized. And you'll get a Boolean sort of output, which gives you the answer for each and every cell of the array. So just like how in loops we have the range function, in array it is called the arange function. So here you can construct an array with very specified, with some specifications. So let's say you want the first 10 numbers with, let's say, a step size of 2, starting with 2. So 2, 4, 6, 8. Yeah. So this is possible. Instead of, writing loops, you are just able to pass it through a function. So this is a classic live example of the vectorization property. Now, the next thing we're going to be talking about is slicing of arrays. So after initializing an array 5, um, okay. Now let's say you want to access a certain portion of this array using the slicing operation. So you can say 5 is to 7. So you'll get 5 and 6 element, 5 till the end. So from the fifth index till the end. You can also do negative indexing. So yes, so let's go -5, -8. Oh yeah, I just forgot to mention -1. Yes. So 5, 4, 3. Yeah. So now we were able to access this particular element using this indexing. Yeah. So in this way, you can access individual elements inside the array using the slicing operation. So the next operation that we are going to look at is reshape and transpose. So what transposing does is pretty simple. So you have array. Now, if you do array.transpose, it'll just take the transpose. This is very basic. The next one is the reshaping function. So let's say you have an array. Let's just reinitialize the array called np dot range of 10. And now you want to reshape this into, you have 10 elements, right? So you can say a 2 comma 5, 2 comma 5. So now print AR. Yeah. So you have successfully managed to, rearrange this array into a 2 by 5 matrix, 2 by 5 matrix. So 2 rows and 5 columns. Another operator is the dot product. So you can easily take dot products using the NumPy dot operation. So you can just say NumPy dot, give the two arrays that you want, two matrices that you want to take the dot product of. And just click enter and it computes it, and it is as simple as that. I would suggest you to go look into some advanced topics like broadcasting rules for NumPy arrays. This can give you some insight on how what are the different rules for dot products apart from the fact that, you know, the number of columns of the first array must be equal to the number of rows of the second array. So there are some rules and regulations on how NumPy dot product has been constructed. So I would suggest you to look into that specifically. So the next feature is the ability of NumPy to generate random values. So the NumPy.random module is able to do this. So if you want a standard normal distribution of values, you can just say, and here you can give the dimensions of 5,5. Oops. Yeah. So here you get a standard normal distribution of values, and these are randomly generated. You can also do np dot. You can also complete the square root of the whole array that you've generated. So let's say np dot square root of the samples array itself. So you can take the square root. Yeah, some of them have NAM because obviously they are negative numbers. This is just an example. And you can also take the exponents of samples. Yeah. So np dot maximum function is another function that is used to compute, that is used to take the maximum values on two arrays and make a new array from it. So I hope these two arrays are similar. Okay, it's 2, 5, and 2, 3. Okay, let's just array and array 2. Okay, let's just run this as well. And now we can run this. Yeah. So 1, 4, 3, 7, 5, 12. So we have a 4 over here. Why? The reason being, let's just go to ARR. Yeah, 2 and 4. 4 was evidently greater, so 4 came in place of 2. And this way, similarly, you can just compare, NumPy just compares the elements and sort of puts it up in the new array. Yeah. So there are a lot more functions, like you can do sorting and a lot more of it. I wouldn't go into too much detail. Whatever I've covered till now is more than enough to just get you started with the NumPy. And as you try to, do different, as you come across different use cases, you will learn about, different options in NumPy or different functions in NumPy that you can use. And one small short tutorial is, it's not possible to cover everything in a short tutorial. But now I hope that you guys have a basic understanding of, how NumPy works, what the know-how of, how to do some basic to intermediate level stuff. Now another feature that is there in the NumPy library is the NumPy financial segment of the NumPy library itself. So this particularly has financial functions, and this is very useful to calculate certain frequent calculations that are performed in the financial world. And let me just try to showcase it to you using some examples. I think we need to install it using the pip NumPy financial. Yeah, right. So never mind. Oh, oops. Yeah. So now let's install the NumPy financial library and import NumPy underscore. Yeah. Now, there are a lot of financial calculations that you do regularly, like computing future value, computing the interest portion of a payment, calculation of internal rate of return, modified internal rate of return, net present value, and so on and so forth. So there are some, you know, functions to assist you in these very frequent calculations so that you don't have to code all of this out. So let's say you want to calculate the internal rate of return for, a set of cash flows that you've been given. So NPF dot IRR. So you have all these different options that are available in as part of the NumPy financial library. So you can say NPF dot IRR given, the cash flows, just taken some values over here and just print it. So for these set of cash flows, this is the IRR. So now you get the brief idea of, some very good features of NumPy especially. So you can look up on this website where you have different functions provided, especially under the NumPy financial package. Don't forget to download the NumPy financial package using pip. So yeah, that's all for this video. Thanks for watching again, and I hope you guys can, try out some financial examples by yourselves. This was just a brief about the NumPy library and how powerful it is, why it should be used. Thanks for watching.